Navigation Basics. We presume that the Earth is a perfect sphere and is the center of the universe. The Earth is rotating around a hypothetical axis N and S and is penetrated in 2 points. The upper point, N, is called the North Pole, and the lower point, S, is called the South Pole. N and S are known as the geographical poles. C is the center of the Earth, known as the core. Any plane passing through the center, C, is known as a great circle plane. The circumference of the great circle that is right-angled to the hypothetical axis N and S is called the equator. This divides the globe or sphere into 2 equal hemispheres, the northern hemisphere where the North Pole is located, and the southern hemisphere where the South Pole is located. The circumference of the small circle A1 with a plane parallel to the equator is called the parallel of latitude. The circumference of the great circle that includes the hypothetical axis N and S, the geographical poles, is called a meridian. Therefore, the line joining N and S is a meridian. The meridian planes intersect at the axis of the Earth. The meridian that passes through Greenwich is called the prime meridian or Greenwich meridian, and this divides the Earth into 2 hemispheres. The hemisphere lying east of the Atlantic, that includes Europe, Asia, Africa and Australia, is called the Eastern Hemisphere, and the other half lying west of the Atlantic, including North and South America, is called the Western Hemisphere. To define a location or position on the surface of the Earth, except at the poles, we use geographical coordinates. As a base and starting point for these coordinates, we rely firstly on the equator and secondly on the prime meridian. The coordinates are the geographical latitude and the geographical longitude. Taking a position L on the Earth, only 1 parallel of latitude and 1 meridian pass through this point. The geographical latitude of position L is the arc on the meridian passing from L that is included between the equator and the parallel passing through L. The latitude is defined as north, or N, if the position is in the northern hemisphere, or south, or S, if the position is in the southern hemisphere. The latitude is measured in degrees, minutes, and seconds, starting from 0 degrees at the equator up to 90 degrees north or 90 degrees south. Every degree has 60 minutes, and every minute has 60 seconds. The geographical longitude of position L is the arc measured on the equator that is included between the prime meridian and the meridian passing through L. The longitude is defined as east, E, if the position is in the eastern hemisphere, or west, W, if the position is in the western hemisphere. The longitude is measured in degrees, minutes, and seconds, starting from 0 degrees at the prime meridian, going up to 180 degrees east or 180 degrees west. As with latitude, every degree has 60 minutes and every minute has 60 seconds. Here are some important navigational terms. You should know these in order to understand navigational data and minimize the risk of misunderstandings. Degrees true, T, stands for direction or bearing that is relative to true north. For example, 90 degrees true. Degrees magnetic, M, stands for direction or bearing that is relative to magnetic north. For example, 260 degrees magnetic. No correction for variation has been applied. Degrees compass, C, stands for direction or bearing that is measured by the compass. For example, 123 degrees compass. No correction for variation and deviation has been applied. Variation stands for the angular difference between magnetic north and true north. Deviation stands for the difference between a compass reading and a magnetic reading, caused by the magnetic fields on the boat. Knot stands for the unit of speed used at sea. 1 knot is 1 nautical mile per hour. You can either say that the boat's speed is 1 knot or 1 nautical mile per hour. Nautical mile stands for the unit of distance at sea. It's based on the circumference of our planet. 1 nautical mile is 1,852 meters, 6,076 feet, or 1 minute of latitude. 1 nautical mile is divided into 10 cables. 1 cable is 185 meters, 200 yards. Directions at sea, for example a landmark, are expressed in degrees. They are measured clockwise and are relative to true north. In this lesson, we'll learn about nautical charts. A nautical chart is a graphic representation of the marine environment and is essential for safe navigation. The mariner uses the nautical chart to navigate and as a worksheet. Using the chart, the mariner lays out courses and navigates the ship safely by the shortest and most economical route. On a nautical chart, we can observe the latitude and longitude scale, the form and nature of the coast, the depths of the water and composition of the seabed, locations of dangers to navigation, we can also see locations of man-made aids to navigation. The characteristics of the Earth's magnetism, tidal information, and much more. We'll study all of these individually. Projection is the process of flattening a three-dimensional surface to form a plane. In other words, it's the representation of the surface of the Earth as a flat surface. Different projections have been developed for transferring information from a sphere to a plane, and each distorts the data in different ways. The projections are, firstly, the conic projection, which includes the simple conic projection, the Lambert conformal projection, and the polygonal projection. Secondly, the azimuthal projection, which includes the mnemonic, the stereographic, and the orthographic projection. And thirdly, the cylindrical projection, which includes the Mercator, the transverse, and the oblique Mercator projection. The Mercator projection is the most common projection used in marine navigation. On a Mercator chart, the lines of latitude and lines of longitude remain parallel, and they cross each other at right angles. The directions can be accurately plotted, and a course can be plotted from one point to another, making it possible to sail along that line. This is called the rum line, by steering a single compass course. The rum line crosses all meridians at the same angle. The shape of an object is accurately represented. Sailing towards the poles, the objects appear larger than they actually are. Viewing a nautical chart for the first time can be very challenging. It can seem complicated if you don't know what you're looking at and what it means. Things you should take notice of when looking at the nautical chart are the title block, where you can see the crest, which is located at the top of the chart title and will ensure your chart is official. The main title, which states the specific geographic area of the chart. The nautical scale identification. Natural scale means the relationship between the size of the chart and the Earth, where the scale gives an indication of how detailed the chart is. Here are the different types and scales of charts. Sailing charts, where the scale is 1 to 500,000 and smaller, are used for offshore navigation beyond sight of land. The general charts have a scale of between 1 to 150,000 and 1 to 500,000 and give wide-ranging offshore coverage with sufficient inshore detail to make landfall sightings easy. Fisheries charts use these scales. The coastal chart uses a scale of between 1 to 50,000 and 1 to 150,000 and is used to show uninterrupted wide-ranging coverage with adequate inshore detail to make landfall sightings easy. Fisheries charts also use these scales. The approach chart has a scale of between 1 to 15,000 and 1 to 50,000 and is used for approaching coasts where great detail is required. Harbour charts, which have a scale of between 1 to 5,000 and 1 to 15,000, are used for navigation in harbours or intricate, hazardous, shoal-infested waters. Bar scales. A bar scale is a graphic scale represented by a line or a bar that is subdivided into nautical miles, feet, or meters. This bar is used for measuring distances on the chart. Elevation contours. These are lines connecting points of equal elevation. They're a graphical way of showing the shape and slope of hills and mountains that might be helpful in identifying them on the chart. Once identified, they can help identify your location on the water. Other factors that you should take notice of when looking at the nautical chart are the depths note. This shows which units of measurement are used to indicate the depths on the chart. You may read soundings in fathoms and feet or soundings in meters. Soundings in fathoms and feet indicates that soundings are in fathoms with subscript in feet. The larger number indicates fathoms and the small number indicates feet. For example, if you see a spot depth of a large 3 followed by a small 4, this indicates a depth of 3 fathoms and 4 feet, or 22 feet, as 1 fathom is 6 feet. Sounding in meters indicates that soundings are in meters and decimeters. For example, you see a spot depth of a large 7 followed by a small 6. This indicates a depth of 7 meters and 6/10 of a meter. You can convert between meters, feet and fathoms by using the depth conversion table provided on the chart. The depths indicated on the chart are all based on chart datum. This could be the mean lower low water or the mean low water or other tidal datum. To avoid grounding, you have to take into consideration the height of tide and the tidal range. Other things you should take notice of when looking at the nautical chart are the chart number. The chart numbers differentiate charts of the same area. Elevations note, which describes the datum used to indicate the clearance of bridges and overhead cables and the elevation of constructions. Notes and warnings. In the title block you may find notes and warnings concerning the nautical chart. By reading them carefully, you'll decide if they're applicable to your voyage. Datum note. This datum note may read WGS 84, World Geodetic System 1984. WGS, or positions obtained from satellite navigation systems referenced to the WGS 84, can be directly plotted on this chart. It's crucially important that your GPS is set to use the datum of the chart that you're using. Chart corrections and addition. In the bottom left corner of the chart, you'll find the chart corrections by year and number which were applied on the chart. Corrections are published several times a year in the notices to mariners. Chart abbreviations and symbols. There's a book called Chart Abbreviations and Symbols where you may find an entire index of abbreviations, a key to all of the chart symbols, and an explanation of the IALA buoyage system. In addition, you may find general features, topography, hydrography, and aids to navigation. Looking at the navigation chart, we can see lots of symbols and abbreviations. Each symbol and abbreviation on the navigation chart has a meaning, representing a shorthand way of covering significant information. The knowledge and understanding of those symbols and abbreviations are crucial for safe navigation. On the nautical chart, you'll see natural features including coastline, relief, water features, vegetation, and supplementary national symbols. On the nautical chart, you'll also see cultural features including settlements, buildings, roads, railways, airfields, and other cultural features. Landmarks including factories, churches, temples, monuments, tanks, and forts. On the nautical chart, you'll also see control points including observation spot and benchmark, symbolized positions including accurate position, candela, and not, magnetic compass including compass rose, variation, annual change, magnetic variation curves, local magnetic anomalies. On the nautical chart, you'll also see ports, including port structures, harbour installations, moles, dolphins, dry docks, and canals. Tides and currents, including tidal levels, charted data, tide tables, tidal streams, and currents. On the nautical chart, you'll also see depths, including soundings, depths in fairways and areas, depth contours, types of seabed, and intertidal areas. Dangers including rocks, wrecks, and obstructions. On the nautical chart you'll also see offshore installations including platforms, moorings, underwater installations, submarine cables, submarine pipelines, tracks, and routing measures. Track and routes including radar surveillance system, radio reporting points, routing measures. On the nautical chart you'll also see areas and limits including anchorages, anchorage areas, restricted areas, military practice areas, international boundaries, national limits, and other various limits. Fog signals including various types of fog signals with abbreviations. On the nautical chart you'll also see lights including light structures, major floating lights, light characters, color of lights, period, elevation, range, disposition, leading lights, lights in line, direction lights, sector lights, and lights with limited times of exhibition. On the nautical chart you'll also see electronic position fixing systems including radar, radio, and LORAN-C. Services including pilotage, Coast Guard, rescue, and signal stations. To navigate safely, you need to have reference books that provide detailed information on tides, radio and light signals, symbols, etc. The principal books are 1. Nautical Almanac, 2. Pilot books, 3. Tide tables, 4. Tidal atlases, 5. Lights and fog signals. 6. Radio signals. 7. Symbols and abbreviations. Let's have a closer look at these books. The Nautical Almanac is updated every year, so you need a current copy. The almanac provides you with astronomical information, tide information, meteorological information, and more. Pilot books amplify information on charts, for example, detailed harbour, approach, and caution information. Tide tables provide you with detailed information on tides in each port. Tidal atlases provide you in pictorial form with the direction and rate of the tidal stream. Lights and fog signals give you detailed information about lights, light structure, light vessels, and so on. Radio signals give you worldwide radio information, for example, coast radio stations, search and rescue procedures, medical advice by radio, and so on. Symbols and abbreviations provide you with detailed explanations of symbols and abbreviations that are used on charts. On a nautical chart, features such as buoys, channels, wrecks, and so on can be omitted or their positions changed. Therefore, a nautical chart should be kept up to date. Published corrections are issued regularly from the relevant chart authorities. New charts are issued periodically. You can correct the charts yourself, or a chart agent can correct them for you. The parallel ruler is used to draw lines and plot directions on a nautical chart. In addition, it allows courses to be measured from a convenient meridian. The ruler is split in half, and the two halves are joined together by pivot points with aluminium arms and handles. Usually they're made of extra strong, crystal clear acrylic. Looking at the nautical chart, let's assume you're departing from point A and you want to arrive at point B. To determine the direction or the true course to follow from A to B, follow these steps. Firstly, connect the 2 points A and B with a straight line and make sure that the course you want to follow is clear of navigation hazards and obstructions. Secondly, line up the parallel ruler with the 2 points A and B. Thirdly, move the parallel ruler by alternating the halves, holding down one half by the handle and moving the other half repeatedly until you reach the nearest compass rose. Steps to determine the direction or the true course continued. Fourthly, place one side of the parallel ruler on the center of the compass rose. As you can see from the example, you have two readings, 110 degrees and 290 degrees. To find which course to use, 110 degrees or 290 degrees, imagine that you start point A in the center of the compass rose so that point B will then show the direction and therefore the correct reading. In your case, point A is at the center of the compass rose and point B shows the direction, therefore the reading of 110 degrees. In contrast, if you depart from point B and you want to arrive at point A, following the previous example, you should follow a true course of 290 degrees. The dividers are used to measure or transfer distances on the nautical chart using the latitude scale. In other words, it's used to walk off distances on the chart. Distances at sea are always measured in nautical miles. 1 degree of latitude is equal to 60 minutes, and 1 minute is equal to 60 seconds. 1 minute of latitude is equal to 1 nautical mile, 1,852 meters, or 6,076.11 feet. Before you measure any distance, look at the scale of your chart. In this example, the scale is in degrees and minutes. To measure a distance, always use the latitude scale located in the same parallel from where you want to measure. Do not use the longitude scale. How do you measure a distance using the dividers? Let's assume you sail from point A to point B. The true course is 110 degrees, and you want to find out how many nautical miles it is from A to B. In other words, the distance from A to B. Place one leg of the divider at point A and the other leg at point B. Next, apply this span on the latitude scale which is closest to points A and B. Read the scale to find that the distance is 10 minutes or 10 nautical miles. How do you apply a measured distance using the divider? Let's assume you calculate a distance of 10.5 nautical miles and you want to apply it in your true course starting at point A, assuming your true course is 110 degrees. Use the dividers and span a distance of 10.5 miles on the latitude scale which is closest to point A. Apply this span on your course, placing one leg of the dividers at point A and the other leg on the course, marking the new position B. We can see that the distance from A to B is 10.5 nautical miles. How do you measure a distance that is longer than the span of your dividers? Assume that you're sailing from point A to point B. The true course is 110 degrees, and you want to know how many nautical miles it is from A to B. However, the distance to be measured is greater than the divider's span. Use the dividers and span a distance of 10 miles on the latitude scale which is closest to point A and B. Walk the dividers along the course as many times as needed until you get close to point B and mark the last point as point X. In our case, we need to walk the dividers 3 times. That makes 3 times 10 miles, equaling 30 miles. Now measure the distance from point X to point B and apply this span on the latitude scale which is closest to point B. On the scale you find that in this case the distance is 4 minutes or 4 nautical miles. So the distance from A to B is 34 nautical miles, 30 miles plus 4 miles.